In this video, I'm going to look at domain and range in context of just a math equation. So remember, domain is the set of all possible input values allowed or used, and the range is the set of all possible output values that result from using the entire domain. Now, first, I kind of want to review about what I talked about in a previous video, so check it out if you didn't see that one at all, or if you're confused about what domain and range are. So just real quick, in terms of a context, we saw that as a tree just grows over time. And of course, the domain is going to be the x values, or the input, which will be the years. So year 0 when it's a seed, year 1, year 2, year 3, year 4, and so on. In fact, I put that in a table, year 0 and 1 and 2 and 3 and 4, and as it keeps growing. And the output will be, well, for our context, was the height, and so that would be just different height values for each year. So you can see here in the picture, each year had a different height value, and I even recorded it in the table. So year 0 was the height of 0, like the seed picture. Year 1 was a height of 1, like this one. Year 2 was a height of 3. Year 3 was a height of 10, like this picture. And then I didn't draw the pictures for the rest of them, but we see that there's an input and an output. And the domain was looking at what's possible, or even we talked about what's not possible. So it made sense for the domain of the tree, the years that it was growing would start at 0 and go all the way up to some amount, depending on how long the tree lived. We kind of gave like a really good estimate, or I would say a very generous estimate of 10,000 years. I bet most trees don't live that long. They only live like maybe 50 years, maybe 100 years if it's really great, or a couple hundred years. Maybe there's some trees that exist somewhere like for thousands of years. But I would say most trees would die from either disease or bugs or like a fire. And then of course the range, though, the range is the y value. For our context, that was the height. And so we talked about what's possible or even what's not possible for the height. A tree would start with a height of 0 when it was the seed, and it would grow taller and taller and taller and taller, but it actually doesn't grow taller forever. It reaches a maximum height. And we talked about the fact that the Sequoia redwoods, they have, I think the tallest one has a maximum height of like 380 some feet. So we just said 400 feet is probably a good max. Maybe there's a taller tree, but whatever. They don't keep going taller forever. So this is our representation of domain and range. In fact, here's a better way to write it using inequality notation. The domain, the inputs, the x's, which was the years, goes from 0 to, we just said 10,000. The range, which was the y's, or the outputs, and of course that's our height of the tree, would go from 0 all the way up to 400 feet tall. Well, what about just in a straight up equation? Well, very, very similar. In fact, it would help to make a table like we did for the tree problem. So I'm going to make a horizontal table, even though I usually like to make a vertical table, but it doesn't really matter. I make a nice long table because we got to consider all kinds of inputs and outputs. Of course, the input is the x, and let's think about that first, the domain. So I'm actually going to start right over here, and I'm going to say, what if we plug in like a 1? So if we plug in a 1, well, what's the output? Of course, the output is going to be the y. Well, we just use our equation. So it would be y is going to equal 1 divided by the 1 that we plug in, the x. And 1 divided by 1 is just 1. So I'll put that in my table. What if we plug in a 2? Of course, what we're going to do is we're going to try all kinds of possible values. So if we plug in a 2, it's just 1 divided by 2, because we plug in 2 for x. That's just a half. And you know what I'll do is, I'm going to put maybe the decimal version here. I'll put 0.5 for a half, because we have the fraction version right here. What if we plug in a 3? Well, of course, the equation just says it's 1 divided by x, or 1 divided by 3. Well, 3 is just, or excuse me, 1/3, 1 divided by 3 is actually just 0.3 repeated. And so 0.3 repeated is our output, or just straight up 1/3. If we plug in a 4, well, that's just going to be 1 divided by 4. And that would be 0.25. And you see that these are just making fractions, which I could put as a decimal. Of course, we could keep plugging numbers in, like we could plug in a 5 as our input, and then so it would just be 1/5, which is 0.2. And we could keep going 6 and 7 and 8 and 9. And let's just skip some and just jump out to 10. And so that would be 1 divided by 10. 1 divided by x. We just plug in 10 for x. And so 1/10 is just 0.1. And again, we could keep going more. We could skip and jump all the way out to like 50. That would just be 1/50 50th, or 1 divided by 50, which is 0.02, if I actually do that division or write it in decimal form. And what you see here is we could keep plugging all these numbers in. Like I could pretty much think I could plug in any number I want. I could plug in like 50.3, or I could plug in pi, and it would be 1 divided by pi, and I would just get a crazy decimal. So I feel like I could plug any number I want in so far. There's no restrictions. I can use anything. And all it's doing is making a fraction, which could turn into a decimal, some crazy number. In fact, you notice that these outputs keep getting smaller and smaller and smaller and smaller and smaller as the input gets bigger and bigger and bigger. Well, we haven't exhausted all possible inputs. In fact, what we might do is we might think about, what about some negatives? You'll notice I'm skipping a special number here, and we'll talk about that in a minute. What if I plug in -1? Well, that's just going to be 1 divided by the -1 that I plug in. That's almost exactly like this one. The only difference is it comes out negative because we're dividing by a negative. So this is just -1. What if I plug in -2 into my equation? Well, that would just be 1 divided by -2. And again, that's almost just like 1/2. It's just -1/2. So it's -0.5. I'm going to have to write these decimals real small. And so we could just realize that, when I plug in all these different negatives, they're just going to come out just like the positive, except it's going to be a negative version. So this would be 1 divided by -3, and that's just going to be -0.3 repeating. And so just like I pretty much could plug in any positive number I wanted, I think I could just plug in any negative number I want. Like I could plug in -4 and get the fraction for that, which is 1 divided by -4, which would just be, that's supposed to look like a 4, which would just be -0.25. And so I could keep doing this over here for the negatives, just like I did the positives, but I feel like I can plug in anything I want. The set of all possible input values that are allowed or that I use. I think I could use anything. Well, hold on a sec. There is a number that I skipped, and I'm going to put it in red. What if I plug in 0? If I plug in 0, that would be 1 divided by 0. And you should realize, and if you don't, check out my video on dividing by 0. But you can't divide by 0. Cannot divide by 0. And remember, what that's called undefined. And so we don't want to do this. So it's like, not possible. It's actually not allowed, right? The domain is all possible values that are allowed or that we can use. Well, we can't do this. So 0 is not part of our domain, okay? Now, we haven't tried like all kinds of decimals or other numbers, but the difficult part about thinking about domain and range from an equation, like if I'm just using this equation here, is it's hard to know what you can or can't use. It's actually more important to think about what you can't use. I think I can plug in a decimal underneath this fraction. Like if I plugged in, if x was, let me just say 7.3, I think I could just do the y value, which would just be 1 divided by 7.3. I don't know what that is as just a regular decimal off the top of my head, but it's just going to be some crazy number. I think it's allowed. So we could see here that the only number that probably isn't allowed is this bad one right here. We can't plug in a 0 because we would get an undefined output. And we don't like that. So what I would say is our domain is going to be anything but 0. One way to say that is to literally just say that our domain, and I'll write it down here, our domain is that x cannot equal 0. That really just means everything except 0. And so our domain is everything except 0. And we just kind of figured that out by realizing and thinking about considering what can we plug in, or maybe more importantly, what can we not plug in, what is not possible. And that was the domain. Now what about the range? Okay, well, we just plugged in all these things for the domain, and the range is everything that comes out, the result. And we see we get all kinds of numbers coming out here. In fact, a whole lot of fractions coming out of this thing. And so they seem to be getting smaller and smaller and smaller. Well, is there anything that cannot come out of this thing? One thing you might think about is, well, can we get like a really big number? And actually, I'll go over here and consider something that actually could be, I'll say, a big number. What if we plug in like a fraction? If I plug in the fraction like 1/10, actually, maybe I'll plug in the fraction 2/10 to help us realize this. Well, what would the y be? The y value be? It would be 1 divided by the x that we plug in. And so let me plug in 2/10. And so 2/10. And now, okay, now how do you do this? How do you do 1 divided by a fraction? Well, hopefully you remember your fraction skills, that we could do it by multiplying by the reciprocal. So it's actually like 1 multiplied by the reciprocal of this, or the flip, which is 10 over 2. And so 1 times 10 over 2 is just 10 over 2. 10 divided by 2, which is just 5. So we can actually get bigger numbers than these numbers like 1 and fractions like half and a fourth and a tenth. We can get bigger numbers by plugging in smaller numbers. I plugged in a smaller number like 2/10, which is really just 1/5. I could have just plugged in 1/5 and I would have got 5 when I flipped it. But we see that we can get all kinds of numbers. But is there a number we can't get out? And the answer to that is actually 0. You can think about, like, what would I plug in to get a 0? What would I plug into this equation to get a 0? Well, the only hope probably that we could plug in was plugging in 0 to get a 0. And we saw that that didn't work for our domain. We actually can't get a 0 out for our range. And in the future, I'll do another video where I look at the graph of this equation, and we can really see that the range doesn't get 0 out. So our range is actually y cannot be 0. And trust me for now if you're having trouble realizing this, but we can actually get everything out except 0. We can plug perfect things in to get anything we want out. The only thing we can't get out is 0. There's nothing to plug into that equation to get out a 0. So here's our domain. Our domain is x cannot be 0, which means everything except 0 is actually okay. And our range is y cannot be 0. That means our range is everything except 0. So there's a domain or range by thinking about an equation. Now, these are a little trickier to decide just by looking at an equation what is not allowed. But I'll do a few more examples coming in future videos for some other equations that you have to watch out for with an interesting domain and range.